Okay, so if you were to, if you had the chance to put up your build your own data center, what are the couple of tasks that you would start initially with once the data center is ready? So the first, probably the first piece of software that you're going to install was your or will be your DNS server, your DHCP server, and another important server, which is your the booting server. So we'll see what this means actually. Okay, so that's what this whole module is about. Install Linux server using pxeboot or Kickstart. We understand what these updates, automatic updates mean. Then we understand the CI/CD, that is what is the CI and CD, continuous integration, continuous deployment, which we talked about. Git, SVN or Git, which is the standard today. Then we learn about Jenkins, and we also learn how to do a small your small how do you create a package which can then be utilized for installation. Okay, and we also learn about the configuration management, that is with Puppet. Okay, so as you know, today configuration management is one big piece of automation software that sits in your whole automation cycle of your data center as such. Okay, so these are things which you're going to cover for this particular module. Okay, so what is the traditional way of installing? How do we normally be installing? Earlier to, or say beginning of maybe the 2000, early 2000 and thing. So the normal way of installing a server has always been that we would use a CD-ROM. Then change your boot sequence and run through this whole process, right? That's the normal way. That's the normal way we used to do at those times, and it continued for quite some time like that, because we did not have these number of servers what we are talking of today. The servers were hardly in the tens range, basically, than the thousands we are talking of today. So that was the standard way that we would provision an OS. Okay. Now, so during, I think during that time, I think it's early 2000, if I'm not wrong. I think, or I don't know when. Yeah, this concept called network booting came into picture. Okay, so what did this intend to do? The intent of this was, now instead of using CD-ROM as a way to install, can we do this installation using using a server located elsewhere? And instead of using a CD-ROM, can I use a common server and pull down your operating system files, boot it, and then do the complete installation? Was that possible? Now that was the attempt which was done using what is called as this network operating system, and we'll see of that. Okay, so here in this slide, he's generally talking about what provisioning is all about. And there are, so this is about an application provisioning stuff as such. We will come to this. Okay. Now, so this is what I was trying to talk about, how the whole installation of operating system would happen over the network. Now, how did this all happen? Okay, so let's try to understand this whole picture about how we could do this installation of operating system. Now, having I used to work pretty extensively with these Unix servers. When I say Unix servers, specifically with the SunSpark and IBM's power servers, they all had this great utility of installing it over the network. So coming from a background of Sun Microsystems, we had this server called Jumpstart server. So what would the Jumpstart server do is it will help you to quickly provision all your systems over the network in minutes compared to the traditional time of installing it through your CD-ROM. And they used a couple of softwares to enable this. Now, the same utility was then, not the same utility, but a similar approach was then adopted for your x86 environment. Though in x86 environment, during those times, we didn't have that much of a network-based installer, but later on when this NICs, basically the network cards, came with a particular chip embedded into your network card, which would search for these so-called booting servers when you actually start. I mean, you should have noticed this sometimes, that a client's, your DHCP client looking for any, and I'll show you that. I'll show you that whole implementation in the lab as well, and we can do that today. Very surprisingly on my on a virtualized platform itself. It's become so advanced as of today. Okay, so today, as I said, the first two softwares what you would do installing when you in a fresh data center is, first you would do a DNS and a DHCP, and then you followed with one of these tools, either a Kickstart or rather a cobbler, and there are other tools like Foreman, and I think there's one more which Dell uses, Crowbar. So we use one of those tools along with the rest of it, the Kickstart and various other tools that we will see as we go along. Okay, so this booting. So one of the key requirements of provisioning is the hardware server's ability to boot over the network instead of the DVD. A pre-boot execution environment is one of the methods that allows to boot over a network and install operating using the remote environment. So these installs were actually called as Pixie boot environment and things like that. Basically, it's a combination of protocols which enabled this booting of your operating system, booting of your server over the network. Okay, so it depended upon, as they say, 3 protocols. Today, actually, we do not require NFS. We can just do it with your DHCP and DFTP. The earlier NFS was the way to do. Today, as I said, NFS has slowly been replaced, and we predominantly try to use HTTP as the protocol for the way to go. Okay, so what did these systems come with? All these systems came with a specific network chip which was embedded in your network card, and what this would do is when this starts up, when your operating system, when your server starts up, the first thing it will try to do is get an IP address, and that is why you require a DHCP. Okay, it will try to get an IP address. Once it gets an IP address, Now, once you get an IP address, that means he is connected to the rest of the world, right? That's the whole idea, be it internal or maybe external. Okay, so it gets the whole, it gets the connectivity that is required to talk to anybody. It's just like for him getting a telephone number. Okay, once he gets an IP, then he starts searching for the boot server. Okay, he starts searching for the boot server, and boot server is nothing but what is called as a TFTP server, or it is a lightweight FTP server in which there is one code, one executable called the so if you want an operating system to boot today, you require a kernel, right? This guy has a network-based booting kernel. So your machine, your server would locate this server and pull down that small small kernel, which is nothing but sometimes they call pre-boot kernel. He pulls it down from the internet. From your network, that is from your booting server, which is nothing but a TFTP server. He pulls it down, boots it. Okay. Once he boots that small environment, he is now in a position to for him to locate the next step, that is the actual operating system itself. So this guy in turn pulls down the actual kernel from another server. This time instead of NFS, as I said, it's a HTTP server. Your entire actually CD-ROM may be residing in this particular, mounted on this particular. He actually pulls it down from there, and then he tries to install it. Okay, so this is how this whole automation of your server booting happens. Actually, it's a complete installation. Okay, so now how does this whole thing work? Now there are a couple of things before you start before you make this work you have to do. As I said, first thing is installation of your Pixie server. Okay, what is a Pixie server? It's a combination of DHCP and TFTP. Okay, so today, as I said, we don't use FTP or NFS. We prefer to use HTTPD. Okay, so DHCP, TFTP, and HTTP combines to form your Pixie server. Now, what does the DHCP give you? It gives you the IP address. So this guy wants to install the operating system. So what does he do? He will, because this system has a network card, and that network card, as I said, a Pixie bootable, Pixie enabled network card. He will go in search for your, I said a pre-boot, a small software code called pre-boot environment. He first downloads it. Then once he gets a DHCP, then he gets the pre-boot environment, and once he gets that, he will then go in search of your where your actual kernel is, which is residing in your HTTP server. Okay, and remember, all of this actually should work in your what we call as a single domain. So which is very important. Now, the other thing you should remember is, see, when do you use your Pixie boot environment? Because in today's cloud scenario, a Pixie boot environment is one of the most important part, but it is not used extensively. and we will, and I'll tell you why in a little while from now. Okay, so the Pixie boot environment today is utilized to do only two things: install operating system on bare metal, or install hypervisor. I hope you understand this word hypervisor in your bare metal. So this is basically a bare metal, it's basically a bare metal installation scenario. Okay, so we should understand this because in the cloud environment or other environments, we don't use this to install your operating system. The whole intent here is install your operating system for bare metal. When I say operating system, it is two types: either a full-fledged operating system or an hypervisor. And hypervisor could be either a VMware or a Zen server. Whereas when we talk about virtualization, we'll see a little more of the other thing as well. Whereas if it's CentOS, if it's Red Hat, your KVM and if it's Windows Hyper-V, they all come embedded in itself. So this is your first environment. So imagine you want to now install 100 systems, right, in one go in your data center. We could have we could install a couple of Pixie boots, and we can have all of these systems talking to the Pixie boot to do the installation. Okay, now another question arises: is the Pixie server alone okay to do this entire installation? No. Now this is where we have this file called Kickstart. Okay, so I use the word jumpstart server, right? In Spark it is called jumpstart server. In Linux it's called Kickstart. So what is this Kickstart server or Kickstart file? So this is a file which contains a certain information which are common to all the servers. In the sense, when the server installs, it needs it needs maybe a fixed IP. It requires certain applications to be installed, right? It may sometimes require a username and a password to be configured. There are various things that needs to be configured and installed for each system, and these configurations may vary from system to system, right? So all these configurations are kept in this particular file called Kickstart. But if you imagine the situation where there are like thousands of servers, right? Thousands of servers, as on the big five, be it Yahoo, Google, or LinkedIn. Then how do you manage so much of these configuration files? Now that is where these tools like, which I think I just mentioned previously, Cobbler, tools like Cobbler, Foreman, and Koban are coming in a way to help you actually manage these configuration files, as well as probably the respective images itself, right? We are talking here of basically a CentOS. Maybe this environment can have multiple other OSs, SUSE, your Ubuntu, anything. So these servers like your Cobbler servers, Foreman servers, or Crowbar servers, they help you to manage these images and manage these profiles. And what are these profiles? Profiles are the individual attributes for that respective machine, which should get installed when you install your operating system. Okay. So are you getting this by now? Any doubts that you have on this particular part? What PXE environment? This is the first level of automation that you see in a data center. Even before you install your application, you've just started implementing your data center. As I said, and as I keep repeating that, after DNS, DHCP, you actually build your PXE boot environment. And what is PXE boot environment for? To install your software, that is basically operating system and or your hypervisor in bare metal scenarios. Okay. Okay. So I think I did tell a lot about this. So how does this whole thing happen? There is a target machine. Yeah, I mean, sometimes it just helps a little to do to show you with the lab. I'll just show you a little bit. So if I take any of these machines, yeah, I'll just take one of these machines. And if you see here, earlier, I mean, yeah, we had the option to, I mean, the Windows DOS and Windows, those Windows 3.1 all were through floppy, right? So we also have this option called network booting. So if you set network booting in your laptop or servers or whatever, it will start booting through the network. Okay, so this is where the option. For this to function, we have to set up the PXE server. Okay, so that, of course, this whole exercise we are going to see as a part of the labs. And so I hope you kind of understand how this is all working. And I said, so the next step is all the, for your PXE boot to work, you should have your network card with those embedded chips. Earlier, these network cards did not have this, PXE chip. Now, by default, it comes with these chips. I mean, there's no network card which does not actually come with this. Okay, so again, continuation of the same process of how this actually happens. And I said first, I think, so the first step is to identify where your first step is to get an IP address for your machine. Once you get an IP address, we look for where that PXE server is, and it downloads a small boot image. Once the boot image is downloaded, it then searches for your actual booting files. That's your actual kernel. Okay, and once that is all up, your system is able to install. So when you install, what is happening is it's actually referring to this file called Kickstart file. It is in this file where all your configuration information is kept, and based on that, look at the normal installation process. What and all things we are giving. We give a host name, we set your time zone, we set a username, password, we set your server partition, hard disk partitions, right? And you may also say that I want to additionally install all these items. Now, all these steps, literally every step that you go through when you're installing through your CD, can then be automated using this Kickstart. So once you just switch on, and you have this configuration file, it downloads everything, installs everything, and you are ready to. It installs everything, and that's it. It installs, and in the next step, you realize that the machine is already installed and is ready to boot. Okay, so your whole installation will be done in seconds. Not really seconds, or maybe few minutes compared to the traditional. But here it is. What do you need to do such an installation? You just need to plug in your system, power on, and make sure your network card is your network port is connected, and that's it. The entire installation is done. By the time you're back to see the other systems as such, it's basically sometimes also called as unattended installation. Okay, so you can do this with any kind of operating system, be it your Linux world, your Windows world, or your traditional Unix world as such. Now we also added one more layer, as installing the hypervisor in the same way. Okay, so when I say hypervisor, it's basically the virtualization operating system. Okay, so this is basically the flow. I think we would probably be seeing a working a lab of this whole PXE environment. How do you configure these? And we will actually install an OS based on that. Okay, so Kickstart is the process of automatically answering the questions at various prompts during installation. This method is primarily used by Red Hat to perform unattended installs. Okay, and Kickstart configuration files can be built by 3 ways: by hand, GUI, or other methods. So we will be actually creating a Kickstart file to do this complete installation, and then we will see how to create a Kickstart file and then integrate this to your PXE boot environment to do that Linux installation as such. Okay, so it's the same thing about how this whole the whole process works. In the left side, we are talking of how it would work in a manual. So earlier, Kickstart could also be installed through a CD-ROM as well. What happens in this kind of method is you so how does this differ from the general CD-ROM? In a general CD-ROM method of installation, you need to keep giving answers to all those prompts which occur during the install as such, right? Instead of that, we can just give a Kickstart file, give a CD-ROM, and then it pulls up the Kickstart file and it does an automatic installation. Okay, but of course you require a CD-ROM. So if you see, as of starting probably last year or I think as of this year, CD-ROMs or CD read writes are literally disappearing out of the market. You are not going to have CD-ROMs anymore. Everything is now going to be through a USB, in case if you want to use USB. If you see the trend, otherwise in the desktop market, Macs have completely removed out CD-ROM from its collection of the netbooks, right? So that's going to happen. I think in the next 2-3 years, CD-ROMs, the CD rewrites would completely be disappearing. Okay, and this is the other way of installing, which I've talked extensively about using the PXE boot method. Okay, so after you kind of you boot your system, right? It comes to this welcome screen automatically. And it picks up. So if you see down here, okay. So the Linux kernel is made of 2 files: VM linus and initrd. Okay, and what it says is it picks up case is nothing but a Kickstart file. It picks up the Kickstart file from this particular server, and it does this complete installation. So this is what you're actually seeing here. Okay. Okay. So I'll be showing you a detailed demo of this. Yeah, it'll take a couple of some time. After we finish this particular theory, we will do it. It's a pretty long demo though, because there are so many things, like as we saw in the DNS setup, we have to configure to put this in place. Okay. So apart from your automatic installs today, we also have to ensure automatic updates, right? But though there are automatic updates, now this is the first form of automation that kicked in the early 2000s, right? Everybody wanted a tool where we could by push all your specifically in the Microsoft environment on the desktop side, we wanted to push in all these antivirus files. We wanted to then update all your systems to the latest package levels and stuff. So this was the first automatic system updates for the first attempt to do this. earlier, you get your updates in your CD, and then you put the CD, and then you used to update your operating system and all that. So the first attempt to start this automation was with your package. And now you know that everything is okay. You connect to your net and then pull down all your files if you have your licenses. It is as simple as that. But earlier we had this Microsoft management server and things like that to kickstart this whole process. Okay, so applications in Linux systems are organized in the form of packages that contain your binaries, configuration files, and Linux uses Linux or basically Red Hat. Each one has their own packaging system, right? To facilitate the installation, upgrade, and removal of your packages. Now all this, so yesterday we saw, right? We used yum, and that's how we installed all of this. The next question arises: how do you create those packages for you? And I think we will be doing one small package for our application, so that can be distributed like your yum repository. Okay, RPM is a command line tool and keeps track of package version and files contained in it. So what is this RPM and why do you want RPM? Okay, now we have some questions and let's speak to JR. Hi, JR.
Oh, hi. So I was wondering, do you use the same Kickstart method to even kickstart a VM?
Okay.
Or
so
is there any other effective method that you could use?
Okay. So let me explain that. So as a part of today, we have various forms of operating systems. So may I want to call as, though it is not the case. One is installing everything on the bare metal. Once we install something on the bare metal, we may choose to install operating systems on top of that, right? If there is a virtualization layer there. So in that case, what happens is basically installing your VMs is normally done through cloning rather than a Kickstart server.
Oh, okay. So you can do the cloning of Linux cloning even with that.
Yes. So I mean, I'll just show you. It's as simple as this.
Okay.
Let me. If I take this.
Yeah, if you're covering on the further chapters up in the further weeks, I don't want to see it now.
Yeah, I mean, in the sense when I say show you, I mean just to show you what that means all about.
Okay, fine.
But of course we will talk extensively. I just pick one server here. Okay, I right click and then I say clone. It is as simple as that. So so you just clone it. So what happens is. So that's why I was emphasizing as I was doing this, all bare metal installs will go through your Kickstarter.
Okay.
That is, if you want to, today we don't use, I mean, unless it's your desktop, if it's your server side, all server side is going through a hypervisor way, right?
Okay.
When I say hypervisor, we install either a VMware or a Microsoft Hyper-V or a Zen server or any of these things. So the first install, which is the bare metal, will go through Kickstart. But beyond, once the OS is in place or the hypervisor in place, we never use Kickstart again.
Okay.
We go through some kind of a cloning process.
Okay.
Or any other method. Basically, it's the cloning process. And I think sometime back somebody has asked this question: do we install your operating system through a configuration management system? So I told you sometime back, configuration management system is only to update your configuration files, right? Like
yes,
yesterday we saw. But we could use provisioning, like a Puppet and tools to actually install your VMs. So how does that happen? That all happens once your hypervisor OS. Okay, so you're getting this up, getting this stuff?
Yeah, I have another follow-up question. Is that so? When you're cloning, so what happens to the IP? So you have to change the IP, right? The range would be there for an ESXi.
Yeah. See, now good question. Now you're getting the See, this is where once your thought starts coming in and you start putting this whole solution in place. Very rightly said. When you clone, everything gets duplicated, right?
Yes.
Everything gets duplicated.
So that is where, everything gets duplicated. So for a bare metal, if I have a simple Linux install, all that, then I could clone it. But still, I have to change the IP, and I'm sure it will be a range that would be provided when I am having an ESXi clusters. So for example, I will have a class C, some kind of a range, IP will be reserved. So I should be using one of those IP addresses. Am I right?
Right. So let me explain that whole situation to you. Once you clone, your IP gets cloned, your MAC gets cloned, right? Your host name is so everything gets cloned. Everything gets copied. I mean, it's literal duplication. So the first thing that we do is in these environments, we do not clone from an existing system. We create what is called as a template before cloning. So when I say template, what do we mean is we now by any stretch of imagination, we need to do at least one installation of your virtual machine through a Kickstart server. Okay, so having said all of this, I still need to do at least one VM through this process. There is no other way out for me. Else, if I can't do that, then I will have to go through this process of P2V and stuff like that, which is a even tedious process of this.
Yes, exactly.
So if I don't do that, I have to do at least one VM through this Kickstart installation, and that's about it. After that, we only clone. So I create this VM, then I do what is called as a sysprep it's actually a Windows term, which is today applied in Unix. And when I say Unix, I mean Linux as well. Sysprep is a set of is a tool which will literally clean up your entire VM. That means if I go through that process, he will remove my MAC address, my IP address, my machine names, my log files, my SSH files, and anything that may be part of the duplication activity. Okay, so we go through this process. Once this is done, this VM is an absolutely clean image without any data which can be duplicated. It is a absolutely clean image, and then we clone that. Okay.
Okay. So basically, a boilerplate or a templates that you are creating.
Yes.
Okay.
And then what happens is once you clone this, once you clone an existing VM, and when that starts up, it automatically generates a MAC address, it gets its IP address, and it may or may not have a machine name. Now, how do you then apply the other changes, right? You want to apply a machine name, or you want to install something, because it's a clean slate, right? Now, this is where we use your Puppet servers to do the rest of the implementation. So, are you getting this picture in now?
Yes, now I'm getting it. So if you're further covering it on the other classes, I can wait. No, not an issue. But now I got the glimpse how it is.
Why I was talking so extensively is because these are those simple questions which sometimes confuse. And once you can put all this in place, right, you get the full big picture. So I hope to the rest of the class as well. So this is how the whole process happens.
Thank you.
Sure. Okay, so I hope I think these questions are very nice, and it helped us to put in a flow of this whole solutioning, right? And it's most about picturizing the solutioning, the solution. That's where we all get into a problem. And so now very clearly we are able to visualize where your PXC environments are, okay, where your probleming tools would come in, okay, and this whole concept of cloning, though cloning varies from place to place. What we saw because I have a hypervisor on my laptop, that's why we were able to clone. But otherwise, there are other methods to clone and do things out. Okay. So RPMs, Red Hat Package Manager, and why do we require this? Now the thought is, we also need to automate our installation of our packages. Now when I say packages here, it doesn't mean packages which are only coming in that CD-ROM which are released by Red Hat. We may also have to create our own package. So how does this help? Once you create your own package, you can then use the same repository to install this. Now your package may be as simple as a shell script or a Python script, and you're going to use this to actually, you'll take this file and then you convert it into an RPM, and once you convert it into an RPM, you can use yum to install. And this is where this whole process of application automation comes in. Okay, we talk so much of CI/CD, right? So your Jenkins servers, once somebody checks into the code, he then this code is pulled out and using RPM. So RPM is just one of the way of packaging. Okay, there are hundreds of ways to actually, each one creates their own packaging tool and format and things like that. Okay. So this guy, the Jenkins, he checks this out, he takes this code, okay, and he creates a package of it. Basically, we are what we are doing is we are kind of doing a tar of this file, and we are putting a lot of other management information, and then we'll see a process of how we'll take a file, like just one line file, and how to create an RPM, and how that can be distributed as a part of your activity. Okay, as a part of this CI/CD as such. Okay, so we had RPMs. Then why is this yum coming in? Right, this is a little confusion. Okay, so RPM is a tool to develop your packages. Okay, yum is a repository, right? It's a repository to store those packages in a form of a group, so that all the so all dependent packages can also be installed along with that. Okay, so I hope you're getting the difference between RPM and yum. So yum, RPM. So I want to clarify here. RPM can be used to build a package, and it can also be used to install that individual package. Okay, it can also be used to install that individual package. Whereas yum is basically a repository. And yum is not again I want to tell you, yum is not the only form of repository. There are various other forms of repository, and each one can create their own form of repository. Okay, so like I know coming from one of these big guys, each one had their own. They won't even bother to use RPM. They had their own form of packaging, and they have their own form of repository. They'll create their own repository and use it to install. So, but all, as I said, all enterprises would prefer some kind of a standardization, and they use Yum in a big way to do the installation if they're using on the Red Hat, because Red Hat being the largest. But if it is Ubuntu or SUSE, then there are other forms of packaging and then installation. Okay, so Yum automatically resolves dependencies and determines which package needs to be installed in addition to performing a successful package installation. RPM does not do this. It basically packages and installs that individual package alone. Yum also supports the concept of package groups, in which a list of related packages can be assembled into a group and installed by using the group name instead of individual name. So I hope you could have, if I take one of these systems, okay. So if I would do this, okay. So can you see this stuff? You could package your applications into groups. So if you wanted a complete Java platform, and then you can just say Yum group install as a Java platform, or you could have a development platform. So there are various ways you could group it, but these are default groups. Okay, these are groups which exist as part of your existing Yum tools. Okay? But you could group it that way. So Yum also supports, okay, yeah, I've done that. So Yum is capable of downloading and installing packages via various transport protocols like HTTP, FTP, or from your local. And today everything is around HTTP. So no more FTPs and no more NFS shares, NFS way of installing. Everything is got consolidated into the web way of doing things. Okay, it makes easier to maintain groups of machines without having to manually update each one using RPM directly. Okay, so I hope you understand what is Yum and what is RPM as of now. So Yum repository is a central location for all packages, and by using just a Yum command, packages can be installed across thousands of nodes. Okay. Now, the first thing is how to know what your central locations are, right? That is the first thing you need to know. So this is the place. I think yesterday I went here, right? This is the place of these location for. This is the place where you find the configuration file for that particular repository. Now, yesterday when I tried to install Nginx, I couldn't install. So by default, when you install your CentOS, only these repositories come in. Okay, so what are these repositories? Each one of them shows you a repository of some respective application. Now, Nginx does not fall into the standard CentOS repository, because this is an application developed by some company, right? Some company or some organization, and he's not keeping it in the central server of his where his CentOS operating system is. Right? So he keeps in a separate place. So that is why we have to point to that particular server, and that was located at EPL. So if I do, okay, so in this, he will point out, as you see this here, he will point, EPL is a central repository, okay, which is mirrors.fedora.whatever that places. Here, the Nginx is located. Okay, so this path, etcm repos.d, is a place where you find all your pointers to the central server. So if some application is you are not able to install, that means you need to add that particular repository. Example, let's say, yeah, I mean, you want to install, Hadoop. So this may be not located here. So I will have to then go and point. I'll have to then go to that particular repository. So I know it is in there. So where do you go? I would need to go to, say, one of those three standard guys, your what do you say, your Hortonworks or Map or one of them, and they will have your he will have that file, which is nothing but .repo file, telling where your central location is. Okay, so we have a process of going through this. Now, earlier we had all of these configurations in an FTP and VSFTP and all these things. Now all this is dead. We only have these repos through HTTP. That is one thing. We can also create our own repo server and then distribute it as well. Okay, so we will also see that small process of how to create our repo, and this is what happens in an organization. Okay, see, we don't allow any server to connect directly to the internet, right? We don't allow any server to connect to the internet directly. That should not happen. So what do? You create your own repo server within your organization, and it can contain packages from various sources. See, when you create your own repo may be serving Hadoop as well as it may be serving Hadoop as well as it may be serving Nginx. Okay, so it could be one repository with all of these files. So what does the repos contain? It contains your RPM files. And how do you create your RPM? You use an RPM tool to create. Okay, I hope you kind of understanding this now. Okay, so we run through a lot of these. When I say yum and RPM demo, the demo is nothing but running the commands, and we'll go through a lot of these commands, yum and RPM. Okay. Okay, so we can automatically we can set automatic updates for yum and things like that. Now, yeah, we are not going to do this often, and though the concept and the configuration and the packages are there, we are not going to do this primarily because we never update a production server as it is, right? So we do go through we could do a automatic update for your desktop, but that's not the case with a server. We will have to go through a completely different process of updating any server, right? Okay, so this as I said, RPM is one way of actually creating a package. There are various ways to create a package. Why do you need to create a package? Without creating a package, I can't use yum as a tool to install, and that is why you need to create package. So, and how do you and what do you do as a part of the package creation? We take a set of files. It could be, as I said, as simple as a bash script or a Perl script or a Python script, and then we create a .rpm out of it. That is the end goal. Okay, as simple as that. And then copy this into your one of your repositories. So where is this repository going to be? That repository is going to be what you are going to create. Okay. So with root privilege, RPM command will allow you to create a package. So the basic procedure to build is get the source code, make a patch, any changes, create a spec file, and then build it. So it's just two things: get a source, create a spec file, and then run it. And we'll do this. We'll do this as a part of your labs. Okay. So the spec file is a description of a software along with instructions on how to build it, and a file list for all the binaries that get installed. Okay, and it is normally a .spec, a file name with a .spec. This ensures that the spec file remains intact during installation of your multiple RPM, source RPM, for various versions of the package. So, okay. So one thing is, as a part of your, as a part of this DevOps activity, packaging is one important part. But normally you will have a separate team who is handling packaging in enterprise level, and this is some activity. Personally saying, even I'm not so thrilled about. It's a little it becomes a little mundane as it goes along. It's just good to see as a part of your lab and things. But you have huge set of teams sitting and creating these packages. But whereas now I'll tell you how I used to use this. So when I used to write my own scripts, right? When I say scripts, these are Python or Perl scripts, which will do some activity. Could be some monitoring or some, or it could be a small socket program, whatever. Now, once I create these scripts and I have to copy this across my, 8,000 odd servers and things like that, right? I can't just copy as it is. It has to go through a process. It has to. So how do you go through this process? I take this files, convert first into an RPM package. Then you'll have to go through the normal, cab, the ITL process and stuff like that, and then push this into my provisioning server, and then you start applying, right? So you go through this whole process. So in that process, one part was to create my package, because I'm creating that software myself. So in those cases you would do, but ideally, you would not be doing this. It is just good to know that you also know how to do what is this packaging as such. Okay, so this is a standard spec file. I said, right? So how do you package? So to do package, it's very simple. You copy all your files in a particular folder. Okay, there are actually 3-4 folders that you create: source, build, and spec, and things like that, and RPM. So in the spec directory, you'll have the spec file. Okay, it tells you the summary of that whole package. What does package? Its name, its version, etc., etc. Where the build route is. Then what do you need to do as a part of it? Okay, and when you install, what are the directories that you may want to create? Okay, and those entire information about if it is a C file, you'll have to compile that. So all that information is kept in this spec file. Okay, and I'll show you a simple one of this. So this is a general spec file. Okay, it contains a lot of these information. Okay, so you want to create a group, and this is it. Okay, so this is a group that the package belongs to in a high level package tool, and this is how you create a group of files as well. And this is how you create your dependencies. It's in this place where you start creating your dependencies itself as a part of that installation. Okay. Okay, so group is used to tell high-level application program where to place this particular program in its hierarchy, and you can see that. And build root allows you to specify a directory as the root for building and installing these new packages. You can use this to help your thing, and description tells you what are they. So there's a whole set of information that you find in your spec file, and as I said, yeah, when we do one simple thing, you will kind of roughly understand this particular file as such. Okay, this is a continuation of that file. There are a lot of options. Okay, even I won't know much of these. I would only do it. I know a few of it which I have used, but there are a lot of things that can get into. I mean, you have actually a complete position for such kind of activity. These are called the build managers. The build engineers. They go through this complete stuff of creating these packages. There's a complete team, and they would know to such deep level. But as I say, if you are building your own applications in this web environment, we won't have to use so many of these utilities. It's only very limited that we are going to actually use. Okay, and you can apply your patches. Okay, so this the whole process of version controlling and package management. I think there are a lot of that within your within that particular spec file. And there's also this build commands here to use, and once you use the build command, we're going to build it. But anyway, we will see this as a part of that particular whole process. Okay, you also have, if you do not get installed properly, right, cleanup. So there is a cleanup process if things don't get installed. This is where you specify all those options actually. What do you do? When you say cleanup, it's just basically deleting a file, nothing more than that. Okay, but you can specify all that in that particular spec file. So this is what we call as reverting, right? Sometimes the installation fails. How do you revert? It's because of these options which are existing in that spec file inside part of your RPM. Okay, you can also create a pre-install script, a post-install script, and uninstall script. Okay, so I think now we're kind of basically understanding what this, whatever that you do, as a part of a package. When I say you sometimes you install, you sometimes uninstall. Where is that whole process defined? It is here. So we might have quite often seen this in Windows, right? We do this uninstall, install, and where do you specify all that? But in Windows, we go the Windows way. But if it's in Unix, we go through the spec file, and that's why you understand it a little more easy compared to what happens in your Windows environment. Okay, so again, there is a lot of these. Yeah, I'm probably not sure why they have so much included, but you don't require so much of these options to do it. Okay, and you also have a change log. Okay, so that is one of the most important part as the process. And after all that, we are in a position to check if things are installed. So RPM, so as I said, RPM can be installed. Using RPM, we can install a single file, but it does not resolve dependencies, right? I'll show you all those set of commands if possible today itself. Okay, so if you don't have YAM, this is the way to install that single package. I go through this process. Okay, I have a set of good amount of commands which gives you a decent way to go through this. So one of the commands is QA. Command is used to query all the packages which are installed. Okay, so if you want to know what is installed, you can go through RPM minus QA. That is one way to check it. Okay. And Q is used to query a particular package. So you want to just check if this package is there or not. Okay, so that's another way to do that. These are the commands basically. We will run through them. Don't worry on that. And if you want to know more information of that RPM package, we can do a QI, and it gives you all these things which you actually sourced it from your when you created a spec, right? I told you there's a spec file which you create. So that information is got when you use minus QI on a particular client. Then, now, if you want to see the list of packages which are part of your RPM, you can put an L, and it shows you all the packages that are installed in that. Included in the part of the package. Okay. Then, if you want to do an R, RP, it shows you all the dependency packages which are part of the that particular client. Okay. And then, as I told you, I'll go through this as a part of a lab in a very ordered way. For now, just understand that you have these options. So instead of IVH, you could also use an UVH. UVH is says that if the file is not there, install it. If the file is there, update it. Okay. And if you want to do an uninstall, we use RPM -Z. Okay. Any questions? Okay, so that much on your RPM and your YUM, and then the other tool, your PXE. Okay, so we'll start on this version control. You know, earlier version control was that piece of software which had a lot of you know, kind of stealth effect to it. Not much people would reveal much about how this version control works and things like that. And it was kind of dominated by few organizations, and one of the most important, I don't know if you've heard of this company called Rational Rose, and they are the ones who probably made this more popular. And there were various organizations who came with their own version control, and these are all branded products, costed products. And as we stand in 2014 today, none of these are ever in prominence. They are kind of got sidelined so badly by these open source tools. Today, actually, version control is literally run by these open source version control tools. Though there are some still in place, but even if they are off the way to be replaced than anything else. Okay, so version control or revision control, also known as source control, is the process of managing and tracking changes to anything. I mean, people think revision control is, or the version control is only for code. It is for documents, it is for code, and more importantly, from the perspective of DevOps, it is actually configuration files. Okay, so this is where it becomes the most important, and tools like Puppet and so use version control to manage configuration files, or some form of version control is always there in an organization which runs automation, right? Wherever there's automation, there is some kind of open source, version control tool to manage your configuration part, apart from code management. Okay, like now in the places where I worked, you had a complete set of tools. You had one complete instance for code management that went through a different cycle of that had a completely different architecture with higher levels of you know, redundancy and things like that. But we also had a completely different version control for configuration files. When I say configuration files, anything that is required for your infrastructure automation, all of them are kept. So it could be a configuration file, it could be even a spec file of your RPM, right? So everything is kept in this, and it is ideally we will have two different bases, one for your code, one for your configuration management. So configuration management will will ideally have a separate tool, will have a separate instance of version control. Okay, and as we see today, Git is becoming the most popular of them all, but others are still in existence. It is a repository of files. It helps large projects from going out of control by letting individual programmers, writers, or project managers undertake a project from various angles without getting in each other's way and without damaging that can't be undone. Okay, and the most popular. So we actually had CVS, right? That was the most popular of the open source, and then it was a bit complicated, and that got branched out into SVN. SVN is what is used quite popularly in India, and SVN then got it got replaced more like with the Git. Git became more popular. There are other tools like Purpose and Bitkeeper and all that. They are popular, but I eventually see Git replacing all of this, and SVN will also continue to be there. But there's a good chance that Git may replace everything, because GitHub today is becoming the standard way of managing all your codes, right? So this is a good picture of how this entire version control handles. We have multiple developers. They all dump the code into SVN, and then the SVN will have different, or the version control will have different branches, one for staging, one for production, and then and your Jenkins and other tools actually pull it out from here and then do the package management. So you kind of understand how this now. I think the cycle makes it a little more better, right? To understand, because they are pulling out from these areas to go into the staging and to the live, and this Jenkins would then take care of that part as such. So why version control? I think we know it. It is very important for due diligence. It is essential for any form of distributed collaborative development. Okay, so it should not be that asking why do you want. We can't even think of an environment when you're writing a single piece of code why there is no version control, right? It's like that. I think we had a question, Ramdas. Are we going to have some demos on Jenkins? Yes, Ramdas. We will have some demos on that as well. We will install that. Okay. Yeah, I'm not sure whether we'll be doing it in this class, but yeah, the next class is going to be all about all these labs that we want to kind of do. So in any large organization where there are many developers, okay, it's the same thing, and every change made to the source must be tracked, who made the change and why they made the change, etc. Such. Okay. So two most widely used, SVN, Subversion as it is called, founded by Collabonet. Currently it is under Apache, and then HN employs concept of automatic operation that prevents corruption of database. And there are various technologies that are built into it. And the Git, actually Git was created to manage your Linux kernel development. Okay, is a distributed version control system designed by the same guy, the guy who developed the Linux kernel, Linus Torvalds. So Git supports rapid branching and merging, includes specific tools for visualization and navigation. and a full history tree which can be viewed offline, which is distributed and uses peer-to-peer model as the way. Probably it's the peer-to-peer model of Git which appeals to a lot of people than anything else, and yeah, it's kind of becoming the de facto standard for version control. Okay, so this is a centralized form of development. This is the ideal way which you will have in any organization, where be it your source code or your configuration management system. Okay, so you will have your working copies, your devs here, and then updating to a central SVN. Whereas so GitHub is I mean, it's actually built on Git for sure. GitHub is the public source for all these whoever hosts their own code. Okay, and that's primarily for public distribution, and they have a different architecture. We now follow that in an enterprise as such. Okay, so this whole life cycle of a version control. So we start with a commit, and that gets updated, make changes, fix problems. So the cycle goes on and on. Okay, so see, understand this. When you're building a version control, it's one of the most important part of your organization, because that's where your entire code sits, right? So the level of fault tolerance and high availability, which are normally built into a version control system, is very, very high, even higher than sometimes I see in your databases itself, right? Your database itself, the database, I mean, it is as much important today to an organization as much as to a bank holding its account information. Okay, it is such a level of HA and the fault tolerance which are built into these particular infrastructures. Because once you lose this, right, your organization loses your IP. So they're very careful about this SVN. So that's why earlier all these rational rows and all these organizations kind of flourished, because their tools were great, but equally were the complexities of it. And then we did not require so much of complexities which were built into those tools. And then that's why tools like Gits and SVN all came into the market. Okay, so how do we install an SVN? For SVN to work, Apache must be installed and running. Okay, so everything, as I said, these days everything goes through the normal Apache way of HTTP way of doing things. So we create a config file in the root, enable the required module, set up the authentication, and configure your repository. So we can do either an SVN or a Git based on that what you would like to choose from. So Git is the preferred way, but if you want to use SVN, we will as well as do that. Okay, so as with your Apache, you have some modules directly related with SVN, so we need to unhash them and add the following this into your base authentication and Apache and point Apache to where your actual repository is. So this way you are getting your authentication in place as well as your path to where your repos are sitting in for your files. And creating your authentication. So today, I mean, we don't go through this method. We ideally would prefer LDAP integration. Basically, that's what happens most of the time. We go through a simple LDAP authentication to get into those to your SVN system, and you can also integrate LDAP to your Apache, and that's the way the normal. So we won't have multiple users spread out. It's all SSO based today solutions today as such. Okay, so we will also do a demo of that, and Git. It's the same, but as I said, this is more of a peer-to-peer than a centralized form, and and Git has caught the people's imagination for whatever the reason. Maybe because of the GitHub. I truly don't know what is the reason, but Git is what is today got into everybody's imagination, and everybody uses Git. So people who were using SVN have all started migrating to Git, and the usage of SVN has come down so dramatically after this guy has the Git has come in. Primarily because people see it as Git as a great tool, because the entire Linux development is handled through this. So there's no reason for us to believe that this is not a great tool. It seems to be an unbelievable tool, and it is so simple, and that's what adds to it. Okay, so configuring Git, very simple. We will definitely be doing Git. So yum install Git, and we just we have a configuration file, add your few configuration information, and then create a bit of a database, and then you're good to go. It is as simple as that. Okay, so setting up SH into the server with the required change directories and themes if it is required, get your status, and you can also add a little bit of CSS and things like that if you want to use the web way of doing it. Else, we just do through the command line. So I'm sure you must have used the word git clone so many times, right? Pulling down the entire file as such. And we'll do a complete configuration of this. Okay, so so how do we make changes? We'll see how we can edit a file, make some changes in that, and then push it. Right? We'll push it, and then pull it out and see both the changes, and we'll both the original and the changes that we made, both are there, so that we can see how this entire concept. And so for us, what I want to tell you here is we are looking version control tools from the perspective of configuration management rather than code management. I keep repeating this because that's what actually happens in most organizations. The configuration part, the configuration management's version control is what you ideally maintain, and this is not complicated as your code base version control is, and that's normally handled by a separate team, and they're normally handled by the developers. This is what we are doing it for the configuration and not to maintain your code. Maybe when you write your small code, you may maintain it. So it can, as I've also seen that this configuration can also have your small code base. Now these code bases are not the app code bases, but these are code bases which you do for creating some scripts, sometimes writing an application to pull a log file, to push a log file, parsing log. It's your own thing. It's all related with your the automation, not related with that. So that is why our approach to Git is to manage your configuration, not to manage your code. And that's where many times people get confused on how do you want to utilize and position this, right? And as you see that without a version control, it is very, very difficult for us itself to manage it, isn't it? Okay, so we will definitely be doing a Git demo for sure. Then, okay, so this is where there's the whole new concept of CIs and CDs are coming. How Git with Jenkins. Okay, so once the developer commits a code, then the build is triggered automatically. It is triggered. It is once it commits a code, the Jenkins server monitors that. Then the build is and probably after this is done, there may be one more layer where the complete testing is. You build it, you do a complete testing. That will be a different environment. So Jenkins can coordinate all of these activities. When I say coordinate, you actually need to write codes to do all of these stuff. You do the build, you push it into the test environment. Now, this is where Jenkins cannot do that operation. Okay, it can build and maintain it in the, and it is again maintained in the version control. Now, to install it onto a dev platform, Jenkins will not do it. You probably need to have a separate tool, which is the application deployment tool that pulls it out from the GitHub and then installs it on your servers, right? And once it is installed there, it will also do whatever the test. It will do all the tests and all that, okay? And then it can actually let Jenkins know that it is all fine, and if it is fine, then this guy can then release that build into the production tree. Once it is released into the production tree, then the application deployment tool can pull it out and push it into the production environment. Now, this whole process is what we call as your CI and CD. Okay, continuous integration, and this is all about your continuous integration. This whole thing is your continuous deployment. Now, what we don't find in the open source world is that tool for deployment. It could be anything. Okay, it could be a custom build, and of course there are various tools that you get in the among the brand products to do that. From the background which I come, this was also a completely custom tool that was built. So ideally, what happens is after the build, right? When I say build, it is exactly creating the package. That's what it does. Okay, it creates the package and pushes it into one of those yum repositories, from which some tool will pull it down to deploy it. Now, I can do this with two ways today. Okay, some organizations keep a completely different application management tool to do it. Other organizations deploy configuration management tool itself to deploy the application, like Puppet. Puppet can also do application deployment as well. So that is why you find that there is no separate tool to deploy applications, because you already have you already have other tools through which you can actually do it. Okay, so I mean, are you getting this big picture? Now this is probably the DevOps. When we talk about DevOps, people always think about this picture than anything else, right? So the picture is not fully complete, as I said, and you have a repository, a yum equivalent repository where your code, your build resides, and also a testing framework environment where you need to check what you have done, the status of that, and only then you push it into the production. So there's a little bit of code and an application there to do that complete test automation, right? Yeah, once all that is in place, you've actually built a CI/CD. Okay, so what your Pixie Boots and the configuration management tools is basically using this CI/CD to deploy your applications. Okay, so let me see a question out here. Okay, so that was the question regarding how this whole Jenkins thing fits into this stuff. Now, but this is what we want to achieve, right? Today, all the business guys will come and tell me, hey, we need. I mean, especially in the, I'll give you the example of whatever happens in the present day web and the web or the internet organization. you would want changes happening in minutes and hours. You can actually do this with this. If the developer can finish the code, and normally he can, because these are not complicated algorithms, right? Or whatever we do in this in the web environment, most of the developers, that is, I'm saying the web developers or the web app developers, most of the case, the algorithm which goes into it or the business logic are not very complicated. They can be written in hours compared to writing a C code to do probably a memory management within your system. The code there is so complicated, and that takes a long time because there's a lot of discussion. There is a lot of mathematics getting involved in that. But here it is not the case, right? It's not the case. Just like as an example, let's take an example of my favorite tool, the IRCTC. How long does it take to actually build that? It is a short time, but it goes through a lot of testing because since it's an internet facing, any application which is facing internet, you need to go through a lot of security checks than anything else compared to your logic. But your business logic is less. It's less, and it is not complicated compared to writing your system applications, which are definitely at a higher level of logic compared to these things. So that's why we are able to do this whole process. And I can tell you, this process does not go for softwares like your operating systems and say you want to release or say imagine you're developing a virtualized application, not virtualization software. So core algorithm related development will not go through this cycle. Okay, they go through the traditional cycle, and that approach is ideally not changed. But this architecture is mainly focused for internet-related applications, or more appropriately, web applications facing the internet, which requires immediate changes because that's what people love. So that's why you want to change it. Okay, so hope you understand, this full picture what I'm trying to give you here, right? Okay, so yeah, so the Jenkins came in a big way. It was Hudson. So the whole problem of so Jenkins is a copy of Hudson, and Hudson was created at Sun. Okay. And there was a big problem with Oracle as usual, anything with the open source. So Jenkins provides continuous integration services for software development. It's a Java-based application basically. It's a container. Its container is based on Tomcat and works with various version control systems like SVN, CDS, and Git. So the idea is very simple. If Jenkins has to work, it has to get, it has to be integrated to a version control system. Okay, otherwise there is no point with that. And it started originally as an Hudson. I think it's still there. I don't know what the status of that. And then after Oracle claimed the name, Jenkins was coined. Okay, again, again, as I say, this was more targeted towards your website. So it includes a feature-rich web user interface that provides the ability to trigger bills, customize bills, manage resources, manage plugins, and various other things. So you can deploy it as it is. Some guys create their own modules and then do things what are more associated with their environment, but more or less it is the standard installation. But the big guys, the big five, will always customize this to their thing compared to an enterprise world, right? Okay, so builds can be started by a commit to a version control system, scheduling via cron-like mechanism, building when other builds have completed, or requested by a specific build URL. Okay, so various ways. There are mechanisms to start the build process. Okay, and you know what build process means. It's creating a package like your RPM or any other format which are respectively used in those environments. We talk so much of RPM because the most used operating system from the Linux side is Red Hat and CentOS, right? Compared to Ubuntu or SUSE. And though one is used primarily in Europe and the other one is primarily used in Africa, whereas Asian America it's primarily Red Hat and its variants. Okay, so components of a build. Yeah. So we saw that there are various ways to trigger a build, right? Various ways. It could be a commit, it could be a URL, or it could be something any other process as well. Then you can it communicates through various channels. What is the status of your build? Email, your IM or an IRC. Okay, so once the build is done, it has to be pushed into a version control for that to be utilized by the application deployment framework, right, or the application deployment tools. And then the results are saved and you do the test. So it is during this process, this Jenkins can also be integrated to various other tools. Like after this build is done and saved, from here I can probably integrate it to a test tool. Okay, so what he will trigger through maybe another tool to do that build, to install the build on the test environment, and then start the testing of it. And once all that is successful, I can then release this to the production branch, right? I mean, you should be aware that they keep multiple branches in your version control. Your test, staging, integration, it could be anything, whatever that each organization follows. Okay, so once more the flow. So yeah, the developer commits, triggers a job, Jenkins. So I told you, right, the Jenkins server, they have their test automation and tools, and and he probably puts into the test side of it, sends the result, and he sends a feedback to the tester. If all is fine, the tester can commit the change into the production, or the Jenkins itself can change it into the production, commit into the production branch. Okay, and it's from that point onward, it's for the other tools to do this complete deployment aspect of it. Okay, so hopefully now you're getting that full picture, right, of how the Jenkins server sits in this environment where there is a version control server, there is probably a test automation seat somewhere sitting, and this whole process of building your packaging your source code. Okay, and it's not only source code, and I said this whole process. Okay, I mean, again, I talk so much about it. I do not again specify that we are using all this for your automation, right? And then we are again using Jenkins here, not for the code base. It's for automation of the it's the packaging of the tools that we as DevOps use, not for the code, for the code, right? So we also go through this complete cycle, right? Like imagine, let's take yesterday's. We say we want to add, we want to okay, what we say, we want to make some changes into one configuration file. So that also you as a developer will commit to this SVN server, then it is packaged by your Jenkins, and then done a test on the test bed and then pushed it back. Not the code base here, it is configuration files and scripts that go into the automation suite. Okay, so that was pretty interesting, right? To know we could use a lot of these into the Windows environment, and now I mean, you kind of be aware of Microsoft Azure. Fortunately or unfortunately, is also a Unix environment. So they are promoting Windows and Unix in a big way in Microsoft Azure. So and I'm sure once you have a mixed environment, the default thought is to go for open source tools. So Kishore's this stuff, whatever he said, should work in a big way in that kind of situation. Okay, so that is a good understanding, and I hope now we understand the big picture of where these individual tools are sitting, and we are actually putting those a complete picture of the whole automation process in place. Okay, so we will definitely do a Jenkins install. Okay, so here you get, you see, this is something which I didn't see when, yeah. Now, if you do not have the repo info of any app, you just need to pull that. Okay, so once you do this, you are able to install. So what this tells you is Jenkins is not part of the original CentOS repo base. Okay. So that's the answer to why do you require a .repo file. And yeah, you can then, it's very simple. As a tool, it's a very, very simple utility, but what is complicated is integrating through this for to other apps. That's where the catch is. Okay, so we will be doing that demo as well. Okay, now coming to the last part, and this is all about your configuration tools, right? So it's Puppet and Chef has created a big storm on this particular stuff called configuration management. And much before Puppet and Chef came into the market, Yahoo and Google were already in this business with their own set of custom tools. Okay, even before this, there was another tool which today nobody talks about. I do not know whether you've ever come across this tool. So CF Engine was probably the first attempt to create this configuration, and unfortunately nobody talks about it. And you know why this was not a successful product? A very, very strange reason. This was actually built on using C and C++ code. Okay, so which was not possible. See, that's where you know, a lot of people were put off. Once you write code in those kind of languages, it is never easy for normal people to make changes. But how what made you know Puppet and Chef so successful is the use of the language to develop this tool. It was built on Ruby, and everything was on Ruby. So anybody could who understood who comes from a background of either Python or Perl were able to quickly get onto the development stuff on Ruby, and they could start work on it. Okay, so be it Puppet, be it Chef, right? Chef is the other tool for configuration management. Both were built up Ruby. Now, the one tool which appeals to me basically, though not mentioned in this, is called SaltStack. Okay, now SaltStack, okay, what makes SaltStack so different compared to these tools is the way it can scale. See, why do we use these tools? Because we have to handle hundreds of servers, right? Sorry, not even hundreds, I'm sorry, thousands of servers. When you want to handle such kind of numbers, then tools, then you should also have your application scaling. And SaltStack was designed for environments which are of public internet in size, and that was built of Python. And the other tool, which is again becoming popular, is Ansible. Okay, Puppet, Chef, and SaltStack are designed of is of the architecture of what you call client server model, whereas Ansible has tried to push an architecture which is more of server model. That means I'm not trying to install an agent to do my work. Okay, it's a non-agentless base of model, so it appeals to some organizations that way. So various technologies, various architectures to go about doing. Okay, so at this moment, these are the 4 tools which are kind of getting popular. Ansible seems to be appealing to a lot of enterprises, but no way to match Puppet in any way. Puppet is the standard, the most popular among all these. And SaltStack is kind of taking the role more towards internet companies because it can scale in a big way compared to any other tool. So if you have organizations, like as an example, either your Flipkart and Snapdeals and various others, they tend to prefer to use SaltStack compared to use Puppet or a Chef. And Puppet seems to be the standard for enterprises today, and most popular. Okay, most popular among these things. Okay, so I think by now you understand what Puppet is. It's a configuration management tool. Now the word confuses. Because when I say it's a configuration management tool, to many people they think it is CMDB as in ITIL. Definitely not, right? We know that. It's not a configuration management database tool where you'll keep your IP address and host name. Yeah, that is also some kind of configuration, but this is much more than that. It is not an ITIL tool. Okay. And by now you even know the use cases where you will apply your Puppet as such, right? So let's go. Okay, so why Puppet? It is tough to do this on one node. What happens when there are 1,000 nodes, right? It's a simple use case. If there are thousands of nodes, today when we talk thousands of nodes, it doesn't mean that we may have thousands of servers. Sometimes you may have maybe 100 or 200 servers, but you have hundreds and thousands of VMs. That's where the catch is, right? When you have VMs and there is uncontrollable sprawl of VMs, the configuration becomes so very complicated. Okay, so a node need not be a physical instance. It can also be a virtual instance. Okay, so that's what we need to understand as well here. Okay, so Puppet is a configuration management tool that is used to deploy, configure, manage a server machine. Now, if you ask this question to me, can I use, I told you I can use Puppet to deploy virtual machines. Okay. Now my next question arises: Can I use Puppet to install bare metal imaging? That means just like how we use in PXE. Okay, can we do this? We can't, right? Sometimes, so that's where people sometimes get a little confused. Will my Puppet replace even the PXE environment? It can't. Why it can't? For a simple reason. For Puppet to work, once I install my OS, I have to install the Puppet agent, right? So only when the Puppet agent is installed, this tool is ready for configuration. Okay, so you install the Puppet agent, and then the Puppet agent will talk to your Puppet server and pull down all the configuration files. So example, now you see me that every time I want to make a change to my etcresolve.conf, I have to go to each machine, make a change, right? Now I don't have to do that. I can go to my Puppet server and do a push to all these servers to the respective file that I want to push. Or the Puppet agent itself will pull these files when it notices that a new version has arrived. Okay, so as I said, you remember, Puppet is a server agent based architecture. Okay, so it controls all the steps right from bootstrapping to the end of server life. Okay, I just want to qualify this thing. It doesn't do OS installation, but why the statement is there is basically it can also do the complete VM install. When I say when I'm doing a VM install, basically installing the OS itself, right? Okay, can define configuration at the node level, can group them according to roles like web server, database server, whatever, maintain a consistency across node. If a change is done locally, it is rolled back to the original configuration. So what I want to tell you here is this line, if a change is done locally, it is rolled back. Now imagine I made a change in my configuration file in, you say, etc configuration pointing to a different DNS. After I've made the change, you can go back and see if Puppet was configured, if Puppet was installed, it will quickly restore back to the old configuration. Why? Because your server has a list of configuration for that machine. If anything changes, he pushes back. That is another advantage. Okay, it is not about just pulling and pushing. It's also about keeping a consistent configuration throughout its life cycle without your intervention. Okay, so advantages of Puppet: it keeps verifying the configuration at specific intervals. It defines configuration with the help of hosts. Large open source developer base. Okay, I mean that is something may or may not be an advantage. It works smoothly with even large configurations. Language use is very easy, unlike Ruby or others. Sorry, if this line may be a mistake sometimes. It's built off Ruby, but certain portions of this tool is being used by another language called Clojure. Okay, I don't know how much of that portion has gone into the this environment language called Clojure. So Clojure is a language built on top of JVM. So basically, you require JVM for it to work. So there is a little bit of architectural redesign which is happening within Puppet, and I'm not sure basically why they would want to do. Looking at for me, I mean, I said using the salt stack. Salt stack is such a tool that I'm able to scale in thousands. Okay, they are promising that this tool even go 1,000, but there may be very specific use cases where Puppet might have realized that they would want to go in for such a language. But Puppet is not targeted for internet. I'm telling you, no organization from the internet space prefer to use Puppet, but Puppet is a great tool within an enterprise environment. So today Puppet as a tool literally does everything what once a while your what do you call this Microsoft the System Center configuration manager would do, which is updating your OS also. See, Puppet can't do that. Puppet can't do that in a way what the system configuration, this SCCM does, but good enough to install all your applications on top of your OS, and of course the configuration itself, and keep it consistent. That is most important. That means any changes that happens is immediately reverted because of the architecture. There's a server, there's a client, and it keeps in sync continuously. Okay. So, okay, so this is what I was trying to tell you. So Puppet works on a master server model. So Puppet master, this machine contains all the configuration for different hosts. So Puppet master will run as a daemon on this master server. Okay, Puppet agent. This is a daemon which runs on each node and talks to the master. Okay, and the connection between these two machines is made in a secure encrypted channel with the help of SSL. Now, one tool which is in between all of this, see, that is the tool which will actually tell you how much it can scale. It's called the middleware. See, there is a middleware which is connecting your Puppet master, and for your Puppet master, your Puppet host. In between, there is a tool called a middleware. So now this middleware is nothing but, it could be anything. It could be maybe I don't know whether you are aware of these tools like RabbitMQ, and you must have heard before this, IBM had a big tool called MQ series and things like that. So it is the middleware actually which defines how much you can scale. So there is another tool in between that, but I think Puppet is using what they have developed on their own. Then, okay, so how Puppet works? So there is a manifest, there is a configuration DB, okay, and this is all on the master side. There is a report processor, there is a file server, and there is a certificate authority which issues your certificate. So your configurator, your agent, console configurator, it evaluates rather than generates a report, and then it sends back. Now, a manifest is where all your files are stored. What manifest is where the configurations are. Let's take an example of that. Okay. Okay. So this is how it looks like. Your declaration of how your files are, and you use one of those languages which are there in the Puppet. Puppets, I forgot the language name. So you to create this stuff, and then you push it across. So, so the following steps are the steps for Puppet configuration. The client connects to your master server, identifies the configuration according to the client. The master builds the configuration that needs to be applied to the host, compiles it, and makes it ready. The client then pulls the configuration and applies them to the server. So this is how that whole process works. But all these declarations, the configurations, what you do are in normal text format. Okay, so so that way it makes your life a little easy to edit, and you're not making any other configuration changes. So resources, the Puppet code is primarily composed of resource declarations. A resource describes about the state of the system. Example, a certain user or file should exist, or a package should be installed. Okay, so resource is anything. It could be a configuration file, it could be a package that needs to be existing in a particular node. Okay, and you need to declare this at your server side before it can be applied to your client side. Okay, so this is our resources declared. This is a case of a user. So this resource declaration describes a user resource named Mitchell with the specified attributes, and this resource, a user like this, will then be applied across all your systems where it needs to be applied. Okay, and to list all the reports, you can run this command. Okay, so Puppet programs are called as manifests. So manifests are composed of Puppet code and their file names use DPS extension. So the default main manifest is your site, which contains all the configuration for all your nodes as such. And it is from, see, this is the database which is always referred to by the clients to keep the consistency. Okay, and then when we do this, we would kind of get a better idea of this. Okay, and in Puppet, classes are code blocks that can be used, can be called in a code elsewhere. Using class allows you to use Puppet code and make them reading your things easier. But okay, so the class, we will try to write one of these things as such. Yeah, these are the little complicated parts of it. Now, you should need, as a Puppet engineer, you should know how to write these classes, those manifest files. That means you need to understand a little bit of a bit of a coding. Okay, and this is where your skills will come in using these tools. And you need to, as I said, you need to master one of these, either a Puppet or a Chef or a Salt Stack, to do this entire configuration information. And this is sometimes some organizations have a separate team handling all these work together. Okay, so a class declaration occurs when a class is called in a manifest. A class declaration tells Puppet to evaluate the code within the class. It comes in two flavors, normal and resource-like. A normal declaration occurs when included with the keyword is used in Puppet called like example class, and a resource-like declaration occurs when a class is declared like a resource. Okay, so yeah, so include is to pull it from another place, and here you're actually making it appear within the same file as such. Okay. Okay, so module is a collection of manifests and data, and they have a specific directory structure. So modules are useful for organizing your Puppet code because they allow you to split your code into multiple manifests. It is considered best practice to use modules to organize almost all of your Puppet manifests. To add a module to a Puppet, you go into this module. So this is where you bring in what kind of configurations that you would need to apply to a group of a system. So understand here, we are in a heterogeneous environment. Sorry, when I say Puppet is mainly used in enterprises, and enterprises are heterogeneous environment. So you will have sometimes Windows, you will have Unix, and in this situation, you need to organize these templates in a way which can be utilized by various of these guys, and not to get mixed up. Okay, so sometimes you have separate teams creating and using these, building these modules. Okay. Okay, installation. Okay, installing is pretty simple. You just need to, you can do a yum, and then there is a bit of a configuration that needs to be done and you need to do two sides: your Puppet master and your Puppet agent. Agent, as I said, runs on the server side, and the only thing you need to do is just specify where your master is in the configuration file, and then that is good to go. Actually, then the next thing is only to start configuring of what files you may want to push it into it, or what applications you may want to push it into it, and create your groups and various other things. So that's it. Thanks for coming in. We also have a lot of labs that we want to cover up. We will do that. So even if you take a little while on the labs, let's do it. That gives you a complete understanding of this whole product base. Maybe I think Saturday we may take full time doing up the labs because there are a lot of things that we want to do. Your automation, probably your Jenkins, your Puppet for sure. I know everybody wants to see that. So let's go about doing this out probably Saturday and maybe Sunday, and then do the rest of the other modules which are not so much theory and not so much of practicals, but more of theory. Okay. So thank you. We'll meet then on 27th and see you then.